Hello, good evening, everyone. Can you hear me?
Good evening, ma'am.
Good evening.
Before we start, I just want to know, like, if anyone has any doubt from week 5.
Ma'am, I have a doubt in tutorial one last question.
Tutorial 1, is it?
Yes, sir, ma'am. Tutorial question.
Okay. Okay, that might take some time to explain. Maybe, Disha, we can do it at the end. Okay.
Okay, ma'am.
Yeah. Okay. So today is your deadline for week 5 assignment, right? Hope you have
Yes, ma'am.
finished your assignment.
Ma'am, could you please repeat once again what you said?
What?
Ma'am, could you please repeat once again what you said?
Repeat once again what, Disha?
Ma'am, what you said, could you please explain, repeat again?
No. I just asked if all of you have completed your graded assignment because today is the deadline, right?
Yes, ma'am.
Mm. So today we'll do week 6. How many of you have watched week 6?
I watched the first two videos of Week 6, ma'am.
First two videos of week 6. Okay. How is it going? How are you finding it?
Although it's the smallest week, it's again same little difficulty as a Week 5 session.
Sorry, it is difficult from week 5, you're saying?
Same difficulty, like it's little
Same
hard.
difficulty. Okay. Hmm. Okay, so week 6, so whatever we had seen in week 1 and 2 for discrete case, now we are going to do it for the continuous case. So now if we have two continuous random variable, how do we find the joint density? How do we find the marginal density? How do we find the conditional density and so on? And how do we check independence? So everything that we did for the discrete case, we will do it for the continuous case. So in week 6, our topics are joint density. We are only going to talk about two random variables. Okay, so for two continuous random variable. So we'll look at joint density. We'll look at marginal density. We'll look at marginal density. Then we look at conditional density, and we also see how to check the independence. Okay. So these are the major topics. So how do we define so when we had two discrete random variables and uh, we said we were finding the joint PMF. So what we did in that case, so in case of joint PMF, if we had, let's say, two discrete random variable x and y, if they were discrete, and to find the joint PMF, we said fx of y of x comma y is equal to probability of x is equal to x and y equal to y. So probability of occurrence of these two uh, together, right? That was giving us the joint PMF. So now since we have the continuous random variable, now we are going to talk about the density, basically area under the curve, right? When we had the one single random variable, it was more of like the area under the curve, right? So now if you're talking about two continuous random variable, and if we have to say like what is the joint density of these two random variable x and y, okay? So let's say they are, we'll write it as f of xy of xy. So we'll say that this function will be a joint density function if it follows the two properties. So if when we were talking about one random variable, then in that case, what are the properties that our PDF followed?
Ma'am, that is greater than or is equal to 0 and
Hmm.
its total probability is 1.
Yes. So when we just had one random variable, then in that case we said that my PDF would be positive over my PDF would be positive, it is greater than equal to 0, and if we take the integral of this function over this whole support, then it should equate to 1. But now since we have two continuous random variable, here we are instead of talking about PDF, now we'll have the joint PDF. So that is what is the probability of occurrence of these two together, right? So again the properties are going to be same, that is my f of xy x comma y is greater than equal to 0, and second is if we integrate over this whole support dx dy, then it should integrate it to 1. Okay. And similarly, we can even write the support for the random variable, right? So what now we have x and y pair, correct? Now since we are talking about two continuous random variable, now we'll have the support for this pair of random variable. So how do you define the support of any random variable? It is a set of all values of x such that its density is greater than 0. So now since we have again two continuous random variables, so we'll define it as pair of all set of all the pair of xy such that my f of xy over xy is greater than 0. So we look at like a very simple, simplest example just to understand this idea of the joint density. Okay, so we'll look at very simple example, which is so Let's say I have two random variable xy and the joint density is given by f of xy, which is equal to 1 if x, y, they lies between 0 and 1, okay, and 0 otherwise. So how do you think will this look like? How do this joint density look like?
A square of 1 into 1 units.
No, it will be a cube now, right? See, now we don't have just one random variable. We have now two random variable, right?
Yes, ma'am.
So let's say if I have this y-axis, let's say this is my x-axis, this is my z-axis, okay? So somewhere maybe we can make a, so the height would be 1 because my f of xy. So on the z axis, you will represent your fxy. Okay. So this is also, this is given to be 1 and xy lies between 0 to 1. So we can just think of it as a
Ma'am,
cube. Yes.
ma'am, your voice is little low.
Voice is low. Okay, wait. How about now?
Fine,
It's fine,
ma'am.
ma'am.
It's fine. Okay.
Ma'am,
Yes.
how are we supposed to account for the z coordinate in the three-dimensional coordinate system when we have only x and y?
How do we account, like, how do we think of Z axis as Z? You mean, what do we mean by Z axis here?
In the three coordinate x, y, and z axis system, the z axis which you take as the height, how do
Hmm.
we take into consideration?
Yeah, so this height is here, this f of xy.
Okay,
So, right?
okay, ma'am.
So my x, let's say this is on my y axis. This is my x axis, okay? And I have so x is varying from 0 to 1, y is varying from 0 to 1, and this height. So I will have to now my fx is 1, so the height is 1. So since this is like a uniform density, so it will form a cube of volume 1.
Okay, ma'am.
Yeah.
Ma'am, what is the question that we are trying to answer here?
Yeah, so no, the question that we're trying to answer here is so the first thing was like I had two continuous random variables. So I had my xy, so they are continuous, and we have defined a joint PDF for this continuous random variable. So that is defined by f of xy to be 1. And how did we define it as? Like for x and y lying between 0 to 1. So basically for this is x, this is y. For over this support, my joint PDF is 1. This is what we are saying. So this is the 2D picture. This is the 3D picture. So this was my support. Now we are saying over this support, my density is the joint PDF is 1. Okay. So the question is like if like this is a very simple setup. Now if we want to find the probabilities in this case, like various probabilities here, how do we do it? So this is what we want. So for example, we want to know what is the probability that my x lies between zero point 0.5 to 0 and y lies between zero point 0.5 to sorry 0.5 0 to zero point 0.5, right? So now what happened? So this was 0 to 1, right? Now we have x varying from 0 to zero point 0.5. So x varying from 0 to zero point 0.5. So let's say this is my zero point 0.5 and y varying from 0 to zero point 0.5. So now we have this area over here, right? So let's say if you have to see it in the 3D picture. So let's say if this is my zero point 0.5 and this is my 0.5y. So this is, we want to know what is the probability that my x and y lies in this rectangle, right? This smaller rectangle where x is between 0 to 5 and y is between 0 to 0.5. So what is the probability of this xy lying in this region? So it will be more like you need to find like what is the volume that it um, occupies, right? So whatever volume you calculate, that would be your probability, right? So basically this is the idea. And if we want to like find it through this 2D picture, so what is the probability that this x lies between 0.5 to 0.5?
Is it
What
1
will
by
you
4?
do? It is 1 by 4, yes. So this here, what it will be, like, so how did we define this? So you'll have to do double integral of, to find the probability, let's say we use it by, we find it by double integral. So it will be double integral of f of xy dx dy. And how is x varying? X is varying from 0
0 to
point,
0.
sorry, 0 to 0.5, right? And y is varying from 0 to 0.5, okay? And how is f of xy defined here? It is defined as 1, okay? So this becomes 1 times dx dy, 0 to 0.5 and 0 to 0.5, okay? So how do we integrate how do we do the double integral? So what we do is like we'll have to let's say first we integrate this region, okay, like integrate this,
Yes, ma'am.
okay. So let's first integrate my f of xy with respect to dx with respect to x. So how it will look like? So I will just keep my 0 to 0.5 outside, and if we integrate this 1 times dx, it will be just x. And how would this x vary? It will vary from 0 to
0 to
0.5,
0.
right? And again I have dy outside, right? And if I solve for this, I will get 0 to 0.5. This is 0.5. Let me write it as 1 by 2 dy. Okay. So now I will
Yes,
integrate my 1 by 2 with respect to y. So it will be
yes,
nothing
ma'am.
but 1 by 2 by 0 to 0.5, which is 1 by 2 times 1 by 2, which is zero point
1.
0.4. Sorry, 1 by 4. Okay, very simple integral.
Yes, ma'am.
Okay, so
Ma'am, if
similarly, you
the
can
x, y,
calculate these
x, y
probabilities
range are,
for, sorry, can you repeat?
ma'am, if the x, y range are very different as you are taking 0 to 0.5. Hello?
Uh, am I audible?
Yes, ma'am.
Can
Yes,
you
yes, ma'am.
tell me
Yes,
again?
ma'am, here you are taking the x and y lies between 0 to 0.5.
Hmm.
If it is lies between any random uh, value, then
Hmm.
uh, we have to also do this type of integration now.
Yes, so this was a very simple case. Like here, integration also was not required because I know that the distribution is uniform. So I could have just calculated the area and I would have gotten the answer. But just to show you the integral part, I have done it. So like this is a cube, right? Cube of volume 1. Now what we are saying is the first question was what find the probability that x lies between 0.0 to 0.5 and y lies between 0 to 0.5. So I could have just calculated this area and I would have gotten the answer, right? So 1 by 5, zero point 0.5 times zero point 0.5, it is nothing but 1 by 4. You can take different values also. Let's say my x lies between, let's say find the probability that my x lies between 0 to 1 by 3 and y lies between 1 by 4 to 1 by 2. Okay, how will you do this? How will you do this?
Ma'am, what is the
Will
distribution for this?
it's same. I'm talking about the same distribution, same joint PDF.
Okay,
by
ma'am.
double integration.
Ma'am,
So,
f
Ma'am,
x by dx dy in double integration.
yes, so we'll do the same thing. We'll do the same thing. So now our limit are varying. So before we said that my x lies between 0 to 1 by 3 and y 0 to 0.5 and y also lies between 0 to 0.5. But here now the limits have changed. The range, the support has changed for x and y. So what
Yes.
is this? This is going to be again 1 times dx dy
Dx dy
where x is varying from 0 to 1 by
0
3
to 1 by 3.
and y is varying from 1 by 4 to 1 by 2. Okay.
Ma'am, integrating x first and then y
Yes,
is the
it
same
doesn't
as
matter. It is same.
okay.
So this is also equal
Order
to
doesn't matter.
order of integration does not matter. Okay. So this is also
Okay.
equal to 1 times dy of dx where y is varying from 1 by 4 to 1 by 2 and x is varying from 0 to 1 by 3.
Okay.
Okay. So you just calculate, I mean, do the integration and it is, you will get the probability. So again, what does this mean? So what does this probability mean? So it is like, um,
ma'am, what is the answer for this 1 by 12?
it will be, calculate the area. So yeah, 1 by 12, 1 by 4 times 1 by 3. Yes, that's right. Okay. That is the
Yes,
answer.
ma'am.
You can just cross check. Now, let's say if we talk about, these are very simple, like we're just giving the range of x and y, and we were asking you to calculate the probability. But what happens in general? Like, what about if we have, let's say, what is the probability that x is less than 2y? Okay. So how will you do this? It's the same. We are talking about the same PDF, same joint PDF.
Ma'am, this is the same as plotting the graph and finding the area, right?
Yes. So again, my fx is same. I'll just write it here. So fxy is same as this, where both xy lies between 0 to 1 and 0 otherwise. Okay. Um, all right. This is the joint period that was defined. Now, uh, how will you solve for this? So how does it look like? If we plot the 2D picture, so this is my x and this is my y, and I'm saying x, so x is less than 2y, right? This is the reason that we have to see, reason where x is less than 2y. So for that we need to plot x is equal to 2y, right? So plot x is equal to 2y. So how will x is equal to 2y look? So if for y equal 1, we'll have x is equal to 2, right? So something like this, let's say this is my x is equal to 2y. Okay, and my support of xy is 0 to 1, 0 to 1. Maybe I'll just so this is 1 and this is 1. Just draw the support. Okay, and like this is how it will look like, right? So what is the probability that x is less than 2y? So which reason will you shade here? This is the line x is equal to 2y.
the below part.
The below part?
Below 0.5.
Below 0.5?
Yeah, because 2y has to be less than 1.
Ma'am,
2y is
what is
greater
the
than x.
range here?
Ma'am, above region.
Oh,
Support, ma'am.
okay, maybe before going to this example, let me do one more example. Wait. So, what about probability x is less than y? So let me first draw this. So this is my x is equal to y, and what is my support? Support is set of all xy such that xy lies between 0 to 1. So this is my support, 0 0. This is my line, x is equal to y. So can you tell me which reason is y greater than x?
The below.
The below part.
Ma'am, above one.
Above one.
Above one, ma'am.
This is the
Above
above
one.
part, above one. This is not the below part. So we are saying y is greater than x. So if you take any any pair over here, over this reason, you will have y to be greater than x, right? Because at this line x is equal to y, at this line, my x and y are same. But if I take any point in over this reason, this shaded reason, my y would be greater than x, right? Any pair, right? This is
And ma'am,
intuitive,
in
right?
the
You can
below
say it.
region, x will be greater than y. Is that right,
Yes,
ma'am?
yes. So this reason is x
Okay.
is greater
Thank you,
than
ma'am.
y, and this reason is x is less than y. Okay. Now,
Ma'am, can you
okay,
explain again?
okay. See, so this is my x, this is my y, and let's draw our line x is equal to y. Okay. My support is what? My support is set of all pair of xy such that they lie set of all pair of xy where they lie between 0 to 1. So this is my 0, this is my 1, this is my 1. Now what I'm saying is that this reason is like over this line x is equal to y, all the pair of xy are same. I mean x will be equal to y on this line.
Yes, ma'am.
Now if I take any point here, so this would be, so if I take any pair xy, so this would be here, what? Here x would be greater than y. This is x, this is my y. Can you say this, that x is greater than y? It is greater than y, right? X is greater than y. No? Yes?
Yes, ma'am.
So this is not just this x. You take any x. Let's say I take a xy pair here. So again, my x would be greater than my y. Any point you take over here, over this region. So over this region, any point you take, any pair you take, this region would be x is greater than y. Whereas this region,
Ma'am, here always x greater than y lies between the below the line.
below the
Am I
line.
right?
Yes. So
And
this,
y greater than x is above the line.
yes. If you have any confusion, pick some point and see what is happening. Then it will be more
Yes, ma'am.
clear.
Also put some point, then we can get the lies of area under below the line or above the line.
Okay, let's see this. So let's take this point, okay? So is this point, like what is happening? Let's say this is my xy. So here, what is the relation between x, y? Is x greater than y or is x less than y? So
X
this
is
is
less
my
than Y.
point.
X
I
less
take
than y.
x is less than y, right? Because this is above this line. So y is bigger, right? If I take
Yes, ma'am.
any point over here, so again this point is above this line, right? So here, whatever x I take, so let's say this is, so this was my x, right? So at this point, my x and y would be equal. But the moment you go up, my y becomes bigger. So this whole reason, the yellow shaded reason is x is less than y, right? Hope this is clear. So, okay. So now coming to our original question, the question was, what is the probability? Now we identified that this is my reason. This purple shaded reason is area is our interest. Now, what is the probability that this happens? What is the probability that x is less than y? So how will you find this probability? How will you find the probability that my x is less than y?
Probably it's double integration of y from 0 to 1 and x from 0 to y.
Y from 0 to 1 and x from
0 to y.
0 to y, is it? Are you sure this is how we should do it?
X from 0 to 1. No, x is
Okay.
also going from 0 to 1.
Okay, so this yellow shaded reason is like we have to find the probability for this reason, right? So this is probability x is less than y. So we'll do integral, double integral f of xy dx dy and over the support of x, support of y. Okay. So my fxy is again what? This is 1 dx dy. Okay. And how does x vary? My x is varying from 0 to 1 and y is also varying from 0 to 1.
Ma'am, from where you get x is varying 0 to 1 and
Okay. Mm, I'll make this picture again.
or ma'am, your voice is low.
Oh, my voice is low. Hold on.
It's fine for me.
Is it okay now?
Yes, ma'am. Okay.
Okay. Yeah. Um, see. So this is my y, this is my x, and this is my reason where x is less than y. Okay.
Less than y.
Hmm. Now we have to find the probability that x is less than y. So what we do is we have this reason, okay? So let's say I'll just not write the limit first. I'll write it later.
Ma'am, why you've written 0 there?
Where? Oh no, it is mistake. It is 1. Okay.
And ma'am,
So
fxy is given as 1.
yes,
Okay,
it's the
ma'am.
same question, continuation of this example. I mean, if for this example, we actually do not have to do the integration, but later we'll work mostly with integration. So I'm just starting with integration for you. Okay. Okay. See, we'll have to do the integration f of xy dx dy over xy. Now we know that f of xy is given to be 1, so 1 dx dy. So let's say first I want to do the integration with respect to x. Okay, so whenever we have to do the integration with respect to x, so what we do is we draw a horizontal strip parallel to the x axis. So this is my, let's say this is my horizontal strip. Now you need to see that how is this varying. So this was x is equal to y, this line, right? And
Yes.
what is this? This would be x is equal to 0, this line,
Yes, ma'am.
right? This line is x is equal to 0. And what is this line? This line
X
is
is
x is
equal to
equal to
Y.
y. So how is, like, if we have to take the, we have to integrate with respect to x. So we are making a horizontal strip parallel to x axis. Okay, so I made a horizontal strip, and now I see how does this x and how does x vary. So like my x start from 0, so I'll put the limit as x is equal to 0, and where does it end? It ends over here, right? It ends over here, right? And what is this? This is x is equal to y, right?
Yes, yes, ma'am.
This is y. So I will put the limit from x is equal to 0 to y. Okay. And now I will look at y. So how is y varying? Y is varying from 0 to 1. Now since I have fixed my x to vary from 0 to y, I can now just take the limit for y from 0 to 1. Okay. So if we do this integration, what we will get? This would be x, and how is the limit varying? 0 to y dy. Okay. And what is this? Again, you have y varying from 0 to 1. So this would be y minus 0 dy. Okay. And what is this? This is y dy, where y is varying from 0 to 1. And what is this integral? This is y square by 2. So 0 to 1, it means this area is 1 upon 2. Is this okay? Is this clear?
Ma'am, we have to always draw the line.
You have to this the blue line horizontal strip that we drew.
Yes, ma'am.
I am telling you just for you to understand like how to take the limit,
Okay, ma'am.
because in many cases the functions might vary differently and you will have to decide how do you take the limit. So once you have fixed your limit of x from 0 to y, so it can be any horizontal strip, right? Let's say I draw one, I draw horizontal strip here. So my x is varying from 0 to y. So it ends at this line, which is nothing but y. So x varying from 0 to y. Any line you draw, you see, my x is always varying from 0 to y, right? So that is why we have written our limit of x from 0 to y. So once we have fixed this limit of x, and I know that my y is varying from 0 to 1, so I can just integrate, take the limit of y from 0 to 1. But um, let's say if I have this, so I have my x, I have my y, I had my x is equal to y, and this is my support, and this is the reason for which we have to find the probability. So this is x is less than y. Okay, this is one. Now if I do the integration with respect to y first. Okay, Let's say I want integral of fxy dy dx. So can someone tell me what should be the limit of y I should put?
0 to 1.
0 to 1?
X to 1.
Yes, ma'am.
It will be not 0 to 1, it will be x to 1. It will be x to 1. See, before we were integrating in the previous case, we were doing double integral of f of xy dx dy. Since we were doing the integration with respect to x first, so we made a horizontal strip parallel to the x-axis and we saw how is my x varying. So we found that my x was varying from 0 to y. Now in this case, what we are doing is like we want to integrate first with respect to y. So if we have to integrate with respect to y, we'll make a horizontal strip now parallel to the y axis. The same thing like when we were first integrating with respect to x, then we made a horizontal strip parallel to x axis. Now if we have to integrate first with respect to y, I'll make a, sorry, not horizontal, I'll make a vertical strip parallel to y axis. Okay. So now since I have made this vertical strip which is parallel to y axis, now I should see that over this region, right? Over this region where x is less than y, how is my y varying? So any line we draw, you see that your y is varying from this line, right? This point which is y, this is y is equal to x, right? And it is going till max till 1, right? So I will take my y limit of y to be from x to 1. So any line you draw, so any vertical strip you draw. So you see your first, I mean the limit of y, the lower limit is it's starting from this point on this line, which is y is equal to x. So the lower limit would be x and the upper limit would be 1. Okay. And now since we have fixed our limit for x over here, and I can see that my y is just simply lying between 0 to 1. So sorry, x is lying between 0 to 1. Okay. So if we do this, if we solve for
Ma'am,
this,
if we don't draw this vertical strip, is there any other way to find out the limit?
I think that's the easiest way to find the limit, I would say. Otherwise, it gets confusing. How else would you find the limit? I mean, without, like, if you are very fluent with solving for this double integral, then you won't even have to draw the strips. You can just simply say it and do it. But since it's new for you, that's why I have suggested that you draw a strip to see how is your
Ma'am,
x varying, how is your y varying. Yes.
ma'am, this part could you please explain again?
Which part?
Ma'am, how to take a range for
Yeah.
x is less than y.
Hmm. See, see, first, like in the previous, like before, what we did is we first integrated with respect to x, right? This is first integrated with respect to x. So we need to know what is the limit of, I mean, what is the limit of x that you would put. So whenever, so just keep in mind, like whenever you have to integrate first with respect to x, you draw a horizontal strip parallel to x-axis and then you see how is your x varying. So when we first integrated with respect to x-axis, I saw that my x is varying for x, my x is varying. So my x was varying from this 0 to y, right? Any line we drew, we see that my x is varying from 0 to y. 0 to y. So basically you are trying to write this this part, you're trying to write this in terms of y, and then once you write this in terms of y, you can just integrate with respect to y over whatever support of y is. Support of y was, so once we found the upper and lower limit for this x, we integrated for this. So we integrated this and we got at the end we got this integral, right? We got y dy, and now I know that my y is varying from 0 to 1, so I can just integrate this. Similarly,
Okay, ma'am.
when first we want to integrate with respect to y, let's say I want this, I want to first integrate with respect to y. So whenever you have to integrate first with respect to y, you will draw a vertical strip, right? I have drawn a vertical strip parallel to y axis, okay, parallel to y axis. Now again you see how is this y varying. So my y is starting from here, y is starting from here, and what is this y? This y is nothing but x, and where is it ending? It is ending at this y is equal to 1. So that's why I've written y is equal to x to 1. Okay, so once we did this, now I once I did this, after that we will have to solve for this, right? After that we need to fix find out the limit for y. What is this, what is the support of y? It was just 0 to 1. So at the end I integrated between 0 to 1. Okay, so this is how you do the double integral.
Excuse me, ma'am.
Hmm.
Ma'am, what was that scenario that you mentioned a while ago that interchanging the integral would not affect? A moment ago,
Yes,
you have mentioned that. What
yes,
was that
yes.
scenario and what is this? Can you compare
Hmm.
between them?
Okay. Um, it's the same thing, same thing. So what I had said is, where is it? I think I have
Yeah,
not
ma'am.
written it.
You have
Hmm.
written it. You have written it.
Ma'am, just
Okay,
above.
Just above, you have written it. Interchange
I
of
have written it.
integral will not affect. Above
Yes,
this,
on
less
this
than
one.
this thing in black ink. 2.
Hmm.
Ma'am, this line in
Oh,
blue color.
this one,
2.
this one, this
Yeah,
one,
yeah,
this
yeah,
one,
yeah,
this one.
yeah.
Okay, okay. So yeah, so it's the same thing that I mean, whatever we are explaining, it's the same thing. So what I said is that in double integral, like order of integration does not matter. So if I have this joint PDF, I integrate first with respect to x and then with y, doesn't matter, right? So it is going to be same as if whether I integrate my fxy with respect to y first and then with x. So I have even showed this, prove this, right? So for this example where we had to find the probability that x is less than y. So first I integrated with respect to x and then with y, and I got it to be 1 by 2. Then in the second case, I first integrated with respect to y and then I integrated with respect to x, and again I got the same answer, right? You can see this, the same answer. So it doesn't matter whether you first integrate with respect to x or you first integrate with respect to y, answer is going to come out to be same. But you should know how to like do both ways, because sometimes integrating with respect to x first turns out to be simpler, and sometimes integrating with respect to y first turns out to be simpler in terms of calculation, I'm saying. So like if you look at this, oh, look this also, right? So in terms of calculation, for me integrating with respect to x first turns out to be a little simpler, like just little simpler, right? I had to integrate at the end y dy from 0 to 1, which is just y square by 2. But if I integrated with respect to y first, what did I get? I got my 1 minus x dx. My integrand was 1 minus x. So it's little different, little more than what we did previously. Okay.
Yes, ma'am.
Okay, so we'll now move to a general case for the uniform. So for any 2D uniform distribution, so if you have any 2D uniform distribution, let's say I have some region D, you have some region D in which belongs to R2, okay, and we are saying the area, let's say this is my region, let's say this is my xy axis, okay, this is my x, this is my y, and I have some region, let's say this is my D, okay, this is my D, and I'm saying the area of this D is, let's say it's given by mod of D, absolute value of D, let's say, okay, this is my area, it just, we are denoting it as like this. Now what we are saying that if, or we'll say xy will be uniform in D if the joint density of f of xy would be 1 upon mod of t for xy belonging to D, 0 otherwise. Okay, this is a general case. So what we are saying, suppose we have a region D in R2 whose area is given by mod of t. Now if I like my this random variable, continuous random variable xy, like if this pair of random variable is uniform in this region D, let's say if this is uniform, sorry, we'll say this xy is uniform in D if this follows, if my f of xy is equal to, like if the joint density is 1 upon area, 0 otherwise, okay. So this is the definition. Now if I go back to my this cube example, so was this distribution uniform?
Yes.
Yes. So what was the what was xy in our case? So I
It
mean,
was 1.
what was D? What was D?
1.
D was this rectangle, no, not one. This D was this rectangle of area 1. Right? This was my D. Correct. In our example, what we solved, this was the reason D. And what was what is the area of this D? 1, length into breadth, which is 1 times 1, which is 1. So and what was the joint PDF given to us? It was 1, right? For xy belonging to this D, it was 1, 0 otherwise, right? This is how it was defined.
Ma'am,
Yes.
what does D signify here?
What does D signify? So D is a region in xy plane.
Okay, ma'am. Thank you.
D is a region in xy plane. So this is my xy plane and there is some region in xy plane. So we are saying my xy would be uniform in this region if if the joint PDF of x and y is equal to 1 upon area of D. So maybe I can write this as area of D. 1 upon area of D. Okay.
Ma'am, area of D we can calculate or we can use previous ones.
Area of D we can calculate, or
Ma'am, here we can calculate area of D or we can reuse previous one.
no, you can calculate, no. So from this definition, what are we saying? We are saying, so this, let's say this is my region D, right? This is what? This is a unit square of length,
Yes.
unit square, right, of area 1 unit square, right? So what should be the PDF, the joint PDF? What is the joint PDF? It is 1 upon 1, which is 1.
Yes,
So for
ma'am.
xy belonging to D, if my joint PDF is coming out to be 1, it means I would say my xy was uniform in D. And this D is what? D is unit square, right?
So
So
area of D is 1.
area of D is 1, yes. Now let's say we can have, so this was just unit square, but it can be in general anything. Like it can look like, I mean, maybe a circle, right? So maybe a circle in xy plane, or some square in xy plane, anything. It can be anything, okay? Or maybe it can be mix of different reasons, okay? So, but if we say, if we find the area, and if we are saying that my xy is uniform in these region, let's say this is my region, okay? And if I'm saying like both to combine is region D. Now, if I'm saying that xy is uniform in D, it means what we are saying. We are saying that f of xy is nothing but 1 upon area of D for xy belonging to D, 0 otherwise, okay? We'll see more examples from this once we finish all the topics.
Ma'am,
Like, yeah,
ma'am, so in the above example, we have to add the circle and square areas both.
yes, yes.
Okay, ma'am.
So that would be area of D.
And then ma'am equate to 1, or
Equated to 1?
how do we, because
No,
usually we
then,
consider.
no. What I'm saying is that my xy is uniform in D, right? And what is this D? This D is these two reasons, okay? These two reasons are my D. Now, if I'm saying if xy is uniform in D, it means that their joint PDF, the joint PDF of x and y will be given by 1 upon area of D. Okay. So, whatever area we calculate, the joint PDF would be 1 upon area of
Understood
D.
ma'am, thank you.
Yeah. Okay. So, like whenever you have this uniform 2D uniform distribution case, calculating the probabilities are much easier, because what we can do is, like in our first example, my xy was the cube example. So my xy was uniform in D, and where D was this reason, right? Where D was this reason. Okay, this is my D in the first example. So xy is uniform D, so its fxy is given by 1 upon area of D, which is just 1. So 1 for xy belonging to D, 0 otherwise. Okay. So let's say I take a small reason, sub-reason, whatever. So let's say I take a small reason on this. So let's say this, I take this reason. Now, if I ask you what is the probability that my xy belongs to this reason A, let's say this, I name it as A. So what is the probability that my xy belong to A? Okay.
A
Ma'am,
by D.
So what we will do is, so this is just going to be area of A divided by area of D. So let's say this is 1 by 2. So this is also 1 by 2. So can you tell me what is the answer? What is the area of 1?
1 by 4.
Area of A? 1 by 4. What is the area of B?
1.
1.
1.
So the answer is 0.25. Right? And can you see, like, even with the integration, we had gotten the same answer? This question? The same question, right? Where we solved it for with integration. But if we knew that, I mean, if we knew this concept of 2D uniform distribution, we could have just calculated the area of A and divided it by area of D, and it would have given me the probability, right? So whenever you know that your random variable follows a 2D uniform distribution and you have to find the probabilities of a certain reason, then you just of a certain reason, let's say A, then to calculate the probability, you just find out the area of A, find out the area of D, and then just divide it. So area of A divided by area of D, that will give you the required probability.
But we should
And
know the
both
shape. Sorry.
Yeah, go ahead.
variables should be uniform.
Yeah, it should be, it
Then
should
only it
this
holds.
XY uniformity. Okay. If you knew, if you know that XY is uniformity.
Yeah, so how do we know the shape of that region, whether it's a rectangle or circle?
It will be, so in this case, we had given D to be a set of all X. So it will be given to you. Like here, my D is what? D is pair of all XY such that my X lies between 0 to 1 and Y lies between 0 to 1. This is my D.
Okay.
So it will be given to you, of course. Now here, all the problems we solved was for a cube. Let's do some little complicated problem. So the question is, suppose my xy is, so most of it is I have taken from the lecture. So if you have seen the lecture, it is very much similar. So xy is given to be uniform D, and let's say now I define my region D to be set of all xy such that x plus y is less than equal to 2, x is greater than 0, and y is greater than 0. So how will you draw this region? How will you draw this D?
For x plus y equals to 2, and we'll
Yes.
take the lower part.
Ma'am, first we can find support.
Yeah, so see, it is given to us that x is greater than 0, y is greater than 0. So it can ideally take any value over here, right? Anything over here. But I have one more condition. I have that x plus y should be less than equal to 2. So to draw this reason, I need to draw x plus y is equal to 2, right? So let's say I draw x plus y. So this is my line, which is x plus y is equal to 2. So what reason would be x plus y less than equal to 2? It would be this reason, right? So it follows my x greater than 0, y greater than 0, and also follows that x plus y is less than equal to 2. Okay. Now the question is, can you find the probability? Um, the question is, what is the probability that x plus y is greater than 1? So how will we do this?
1 by 4.
Draw x plus y is equal to
It will be 1 by 4. So
Yes.
First, what is x plus y is equal to 1? So this line would be x plus y is equal to 1,
Yes, ma'am.
right? And this reason would be, this is what? This reason is going to be x plus y less than 1, and this reason would be x plus y greater than 1,
Greater than 1.
right? So what do we have to find? We have to find the probability that x plus y greater than 1. So we need to find for this reason. So what we can do? We can find the area of this reason and divide it by total D. The total was D. But finding the area of this reason seems to be a little difficult, right? This looks something like a, I would say, I don't know, there is no proper. So finding the area of this reason, I mean this reason is difficult, right? I mean not very easy. So what
We'll
can we do? What
subtract the
can we?
area of x plus y less than 1 from
Yes.
that
So
2
what we
by
can
2.
do is we can subtract the area of this from the whole thing. So what is the area of this x plus y less than 1? It is half into
4.
base into height, which is 1 by 2.
Oh, this one.
And what is the area of D?
2.
Area of D is half into base into height, which is 2. So what will be the area of this A? I
3
mean
by
RA.
3 by
So
2.
area of A would be 2 minus 0.5, which is 1.5. So now what will be the probability?
1.5 by 2.
Probability would be 1.5 by 2. Okay. Hope this is clear. So this is how you can just do it. You can get many different curves, and you will have to find the probability. So just calculate the area and divide, calculate the
Ma'am,
area
can
of
you
A.
please explain how you get the area of D?
How did I get area of
D.
D? So what is D? Can you tell me what is D in this figure? The area
X
D is
plus Y
this
greater.
whole thing, this whole bigger triangle is
Yes.
the D, right?
Yes,
This
ma'am.
is D. So how do you find the area of triangle? Half into base into height.
Base
So
into
what is the
height.
length of this base? 2.
2.
What is the length of the height? 2. So
2.
that would be just 2. So my area of D is 2. And what was A for us? A was this
Half.
reason. A is this reason, right? A is this reason. Now, how will you find the area of this reason? It's difficult. So what we did, we found the area of this smaller triangle, right? We found the area of this smaller triangle, and we calculated the total area, and we calculated the difference of this total area and this small area. So the total area was 2, and this area of the smaller triangle is half into base is 1, height is 1, which is 1 by 2. So
Okay,
area
ma'am, got
of
it.
this blue shaded region is 2 minus 0.5, which is 1.5.
Yes, ma'am, got it.
Okay. All right. So you can get many
Ma'am,
different kind of curves.
Ma'am,
Yeah.
is there any way to choose interval of that blue shaded region?
Any way to choose the interval
Uh,
for the blue shaded region?
Interval, yeah. Is there any way
Uh,
apart from
you
this one?
mean you mean how can we find this?
Yeah, yeah.
So maybe I think it would be some complicated. So you can have one smaller triangle over here, which would be and one, I think it will look something like this. You'll have 3 triangles. You'll have to calculate the area of these 3. I think that is what I can think of. Or if you look at it, this is one triangle and one rhombus, right? So you can add these two. So this is one rhombus and this triangle. I don't remember the area of rhombus, so
Okay.
We can look at it.
Ma'am,
Hmm. Yes.
Ma'am, that's a trapezium, ma'am.
Oh, it's a trapezium. Uh,
Yeah, a trapezium and a triangle.
what
How
is it?
did you get the
Trapezium. I
rhombus?
I I, I think it's a rhombus, right? This is
Oh,
how it
that
looks
one.
like.
That
Then this
was
is
one.
rhombus, right?
Isn't it parallelogram?
Yeah, parallelogram. Oh, rhombus. Rhombus means you should have all the four sides equal, right? Oh, correct, correct. Sorry. Bad. No, it is not rhombus for sure. It's a parallelogram. Yeah. Okay, but that looks tricky to calculate the area of that region A. So
Yes, ma'am. Triangle
doing it
is
this way is
perfect.
easier. Okay. All right. Let's move now to. So if you are given any other, let's say you are given, uh, find the probability that maybe x is less than 5. So again, what will you do? You will have to draw the region A and then calculate the area of A and then divide by area of T. That's all. So just draw the figure and calculate the region area of A, calculate this
Ma'am,
total area and then divide.
can you please draw the graph for this x
I
less than y?
Okay.
So first we have to
Okay.
draw y is equal to x line.
No, first is your D. So this is my D. Okay.
Yes, assuming that we have already drawn the above. So in that,
Mm. So now I have no. Okay. Um, so this is my x is equal to y. Okay. So what is y greater than x? This would be this reason. So you will have to find the, so this is my A. Now you will have to find the area of A and then divide it by area of D. Area of A, how can you find it? Is just two triangle. Just find these points and you should be able to find the area.
okay, ma'am. Thank you.
Yeah. So that is how you do it. Now we'll move to the non-uniform case. So this so far we have only been talking about the uniform case, 2D uniform case. Now what about when we have a non-uniform case? When we have a non-uniform distribution. So 2D non-uniform distribution. Okay. So suppose your xy have the joint density, joint PDF as fxy is a joint density. Okay. Um, and let's say you have some non-uniform distribution. It is no longer uniform, right? So let's say I give you x plus y, okay, where again xy lies between 0 to 1 and 0 otherwise. So now if you have to find the probability that your x lies between, again let's say 0 to half and y lies between 0 to half. So how will you calculate it? So since it is no longer uniform, I cannot find out the area of this support, area of, I cannot do, no longer do this area method. So I will have to go back to our integration case. So how did we do it? We integrated our fxy over this support, right? So if we have x plus 5, so how will you find this probability? I will integrate So first of all, this is my support. Okay. This is my support. Okay. Now, this is T. Oh, this is one. Um, if I have to find this probability, it would be double integral of f of xy dx dy. Okay. So what is my fxy in this example?
X plus y.
This is x plus y. So x plus y dx dy.
Dx
Okay.
dx.
And okay. So what is the limit for x? I have to find for
0 to
0 to
half.
half. So x from 0 to half and y from 0 to half. Okay. So let's integrate with respect to x first. Right. So if I have to integrate with respect to x, what will I do? So I have y is equal to 0 to half outside, and integrating x plus 5 with respect to dx means you will have x square by 2 plus y times x. So I will have to treat this y as a constant, okay, because we are integrating with respect to x. So the other variable, which is y, I will treat this as constant. So if I treat this y as a constant, like what is the integration of constant time dx? It will be c times x,
X. Yes,
right?
ma'am.
So if I treat y as a constant, what will be my integration? It will be y times x.
Y.
Now I have to take this upper and the lower limit,
0 to half.
right? 0 to half. So what do I get? This would be y from 0 to half. This is 1 by 4 times 2, which is 8, plus y by 2 dy. It's fine. Now integrate with respect to y. 0 to half, 1 by 8 times y plus y square by 4. Sorry, wait. So you integrate this. So what will you get? You will get y upon 8 plus y square by 4.
4.
The limit is 0 to 1 by 2. So this is 1 upon 16 plus 1 upon 16, right? Which
1
is
by
1
32.
upon 8. So this is the answer. So this is the probability that x lies between 0 to half and y lying between 0 to half. This come out to be 1 upon 8. Okay.
Ma'am, in this case, the distribution of x and y doesn't matter. Whatever distribution it is. Um,
Distribution of xy doesn't matter means what are you trying to say?
I mean, in the previous example, we are given that they are uniform.
Uniform.
No.
Yeah. This
So
is
in this case,
non-uniform case. So how does the graph of x plus y will look like? So when we say uniform, so take this cube example, right? Um, so
mm,
for every pair of xy, I mean, it is a uniform, right? For every pair of xy, you have the same distribution. I mean, same height, right? But for if you look at the graph x plus y, it's not the case. Maybe I have, wait, maybe I can show you. See, this is how this x plus y. So this pink color curve that you see, no, that's violet or pink, whatever it is. So this is your x plus y. So this red axis is your x-axis. Your green line is your y-axis, and your blue is your z-axis. So this violet color curve that you see is x plus y. So you can see any point you take. So any pair of xy you take, I mean, for different points, you're going to get different height for fxy, right? Like for example, let's see. This also I can change to. Okay, see. So this x is my x axis and y is my y axis. The green line is my y axis. Now this whole volume that is formed by this rectangle 0 to 1, x line between 0 to 1 and y line between 0 to 1, this for this support, uh, this is my f of x, right? This is my joint density. So you can see this is uniform, right?
So ma'am, z-axis represent fxy.
The axis represent
Hmm.
fxy, correct? So you can see clearly from this figure. So this whole this whole volume that is being created, the solid, this is your fxy. Okay. While if you look at this, I don't think I will be able to do it here. Yeah, we can do it here, over here also. So this is my xy. Okay. So red line is my x-axis, y line is my y-axis, the green line is my y-axis, blue line is my z-axis. Now this pink curve is my x plus y. Now see how this solid has been generated. This is no longer uniform, right? For my support, right? For support of this xy, this is no longer uniform. So you cannot do this area, like you cannot do that area of a divided by area of t, because it is not uniform. It's changing, right? Hope you're able to get the picture here. Okay. All right. So next we have what is called the marginal density. So when we were talking about the discrete case, we found the from the joint PMF, we found the marginal PMF, and to do so, what we did like a P of x as in summation of my f of or maybe I'll write p of x is equal to x, y is equal to y for y belonging to t of x. I sum it over y. So now since I am talking about a continuous random variable, now we have this xy has the joint density f of xy. So if we have to find the marginal, so if let's say if I have to find the marginal of x, marginal density of x, in place of, so before for the discrete case where we were doing the summation, now here for the continuous case, I will just do the integral. This would be integral of my joint PDF, so fxy xy, and what will like how like what will be my integral, like how, like we'll integrate it over what variable, y, right?
Yeah.
We'll fix x and integrate over y. And how is this y going to, this y belongs to maybe I'll just write support of y. Okay. And if we have to
Ma'am,
do,
both
hmm,
ma'am, both x and y should be continuous, right?
yeah, both x and here we're talking about both x and y continuous. X, Y, both continuous. I mean, from the starting of this week, from chapter 6, we are talking about both continuous.
Okay.
Ma'am, if
So,
we want to find marginal of x, so we need to integrate with the respect to y.
when we want to find the marginal of x, then
Ma'am, then we need to integrate with the respect to y. Or
we need to integrate with respect to y. Exactly. Like it's the same thing that we did in discrete. In discrete, what we did when we had to find the marginal PMF of x, we kept the x constant and we sum it over the y, right? So if we had the joint PMF table, let's say we have x, we have y, some 0, some 1,
yes, ma'am.
let's say some 1, some 2. So if we have to find the marginal of x, we kept this x constant and we sum it over this whole y, right? So similarly, now we are talking about the continuous case. So my um, summation will now be a integration. Okay. So fy of y would be what? It would be f of xy of x comma y dx. We'll integrate it over support of x. This is fine.
Yes, ma'am.
And we call this fx and fy as marginal density. So this
Ma'am, can
is
you please explain again?
uh, okay.
Only the only one, either for X or Y, anything is fine.
See, if we have to find the marginal density of x, then we will integrate my joint PDF with respect to y. So it means we have to keep our x fixed. So let's say if this is my, let's say this is my d, okay? So this is my d and this is my x, this is my y. So I will keep my x fixed and I'll keep my x fixed and I'll vary over y. So varying over y means I will put my limit of y would vary from this point to this point. So this is basically support of y.
So, ma'am, for X limit would be for Y, right?
For x, the limit would be for y. Yeah. So you'll have to
Okay, ma'am.
fix your x and vary over y. For
Understood, ma'am. Thank you.
fy, we have to fix my y and vary
And
over
limit would
x.
be for X. Okay, ma'am. Thank you.
So they are called the marginal densities of x and y. So in the lectures, there are plenty of problems. Um, so I would request you to just go and try to do it yourself. Okay. So let's look at few problems. First, let's okay. First, we'll do the uniform case. The first problem we'll take is the uniform case, and the second problem we'll do for the non-uniform case. Okay. So the first problem, what we had seen my xy to be uniform in D, where D was this unit square, right? And we had said my f of xy is nothing but 1 for this xy belonging to D and 0 otherwise. Okay. So if I have to find the marginal of x, what will this would be? So marginal of x. So in marginal of x, what we will do? This is my D. This is a uniform case I'm talking about. This is my D. Yeah, tell me.
Integrate from 0 to 1, 1 dx.
Integrate. Yes. So I will have to integrate my f of x by keeping my x fixed and varying over y. And how is my y varying? This is my x, so this is my y. Then my y is varying from 0 to 1. Right? And this is nothing but 1, right? This is 1 times dy, which is dy between 0 to 1, and it is just 1. So what is my marginal density of x? So my marginal density of x is equal to 1 for x lying between 0 to 1 and 0 otherwise, right? So what does this distribution look like? This is x is uniform in 0 comma 1. So what are we saying? We are saying the marginal density of x is uniform 0 1. I mean x follows uniform 0 1, right? This is fine. Any doubt?
Ma'am,
Hmm?
ma'am, I have a doubt, ma'am, how you're concluding that it will be uniform.
Looking at this f of x.
Okay, so if it is one, that's why it is uniform.
Yes, it is not just 1, it is 1 and x is lying between 0 to 1. So how does a uniform, continuous uniform distribution looks like? So when we say x is uniform in a comma b, it means my fx of x should be 1 upon b minus a. This follows this, right?
Yes, ma'am. Okay.
So that is why we are able to say that this is uniform in 0 to 1.
It
What
can
about
be
f?
any constant, right? Any constant if we see, then can we conclude it's uniform? Not just one word, any number, constant, 5, 7.
If it was 5, let's say it is not 5, but let's say it is 5. So can you say it is uniform?
No.
No, but we have to actually expand our this as well range. X will be between 0 to 5.
Yeah, then x should be, no, if it is 5, so it should be 1 upon 5, right? If x lying between 0 to 5, then my fx should be 1 upon 5. Are you getting it?
Ma'am, your
Mm.
x is lying 0 to 1 now.
Yeah, the x is lying to 0 to 1. fx, this is right. I am not talking about this. Someone said that my, if let's
Yes,
say
ma'am. I
my,
said that if we don't
hmm,
have one, but any other constant, let's say 5, and
hmm.
then range is given 0 to 5 instead of
So
0 to 1. Currently, we have x between 0 to 1, but if we have between
okay,
0 to 5,
fx is equal to 5, x lying between 0 to 5. Is it a
yes,
uniform
then
distribution?
I wanted to check is would that be uniform or not?
Does this follow this?
Okay, so that's the rule. I mean, we have to check this if
Not
it
a rule,
follows.
not a rule. This is the this is how uniform distribution is
This
defined.
is a PDF for uniform, right?
This is a PDF for uniform.
Ma'am, if five f of x will follow PDF uniform form, then we can say that it's
Yes,
uniform.
if it follows this or any other distribution to say, I mean, not just uniform. If if you get anything, I mean, if you get any effects that satisfies certain known distribution, if it is exponential or if it is some maybe gamma or beta or normal, I mean, any distribution, if your fx follows, if it looks like, then you can say it, but not tangentially. Okay, this was about fx. What about fy? What what would fy be?
It is the same.
Same.
It is going to be same. It
Will
will
replace
again come
by
out to
y.
be 1. Yes, it will again come out to be same. So even y is a uniform distribution from
0 to
0 to
1.
1.
Ma'am, I'm sorry to ask this question again. So I think for the
Mhm.
hour one, it should be 1/5, right? Instead of
It will be
5.
1 by 5. Yeah, that's what I said. It should be
Okay,
1 by
ma'am.
5.
Okay, ma'am. Thank you.
Mm. Okay, so this was about the uniform case. Now we can go back to our non-uniform example. So this is 2D non-uniform example. So what about like what would be fx of x here? So I will just write it. So this is non-uniform. So if I have fxy to be x plus y or and 0 otherwise, can you find fx of x and can you find fy of y? Can you try this? I'll wait for some time.
Yes, ma'am.
Yeah.
Ma'am, could you please show the question?
It's 1 plus y and 1 plus x.
Um, I need to check. I'm not sure about this, but this is the answer you got.
Yes.
Okay. Anyone else?
Yes.
No, I think I made a mistake this time.
X plus
X plus 1/2, ma'am.
X plus
X plus 1 by 2 and y plus 1 by 2.
x plus 1 by 2 and y plus 1 by 2. Okay.
Yes, ma'am.
Yes, yes.
Okay. So this is the answer you got. Anyone else who has any doubt?
I got for fx y plus 1 by 2 and fy x plus 1 by 2.
Maybe we can solve this question. So what is fx of x? How is fx of x defined? So it will be integral f of xy dy and y is varying from 0 to 1. Okay. So 0 to 1 x plus y dy. So I am integrating with respect to y. So my x would be constant, right? So this would be xy plus y square by 2. And how is it varying? 0 to 1. So this would be 1 plus, sorry, x plus 1
1
by
by
2.
2.
X plus 1 by 2. Similarly, if we do for fy, so this would be fxy of dy, right? So, sorry, dx, right? X plus y dx, and x is varying from 0 to 1. So this is x dx, which is x square by 2 plus yx, taking the limit from 0 to 1, and we will have y plus 1 by 2. So the
Ma'am, can
marginal,
we do both question in one line?
both question in
One line.
one line. What do you mean by both question in one
Means
line?
double integration, ma'am.
No, we are finding the marginal, no? Why will we do double integration?
Oh, okay.
Hmm. If I integrate this again with respect to y, I will get 1 because it's a joint PDF. We wanted marginal PDF. Yeah. Okay. Now, so what was the condition for independence? To check
Conditional
the
marginal.
so
Product of
joint,
marginal is equal to.
yeah, joint PDF should be product of marginal. So even here to check if x and y are independent, you do if f of xy is equal to f of x times f of y. That's all. So if you are given that your two random variable, let's say I don't know what the joint PDF is, okay, but this information is given to you that x and y are independent. So if x and y are independent, I can do the product of if I know also the distribution of x and y. So I can just do the product of the marginal densities of x and y, and I will get the um, joint probability, joint density. This is only when we know that x and y are independent.
Okay, ma'am.
Okay. So there were various more type of question that is discussed in the lecture for uniform case. Um, I will do one more over here. So from uniform case to the uniform. Suppose that your xy is uniform D, where how is D defined? D is defined as set of all xy such that you have this 0 cross 0 comma 1 cross 0 comma 1 union, so this union 1 comma 2 cross 0 comma 2. Okay, so how does this look like? What is the reason? So this is my y, this is my x. So 0 comma 1. So this is my x and this is my y. Okay, x cross y. So x is between 0 to 1. So 0 to 1. Y is also 0 to 1. So 0 to 1. So this reason. The next we have 1 to 2. So 1 to 2 and 0 to 2. So 0 to 2. So this is my 2. So this is my D. Okay. So this is my, this whole two, like both of this shaded region is my D. Okay. Now can you find the marginal of this? Can you find the marginal of this? What is fx of x? Okay. First of all, what is the joint PDF? What is fx of y?
It is 0 to 1.
No. I am talking about joint
3.
PDF. The joint PDF of this xy. I mean the joint PDF for this xy. Yeah. This whole shaded region is my D.
Area under that shaded region.
Yes. And what is that?
3.
1 into 2 plus 2 into
1 by 2.
3.
Area is 3. So what should be the joint PDF?
1
1
upon
upon 3
1 upon 3.
for xy belonging to D. 0 otherwise. Now we know this. So can we find fx? What will fx be?
Fx will be integration of y from 0 to 2.
Integration of y.
Integration from y belonging to y.
Integration of 1 by 3
Integration of 1 by 3
And
dy.
dy
dy. And how does y varies?
0 to 2.
0 to 2. Why is 0 to 2?
0 to y.
0 to
Why
1 and 1 to 2. Maybe there are 2.
there will
0
be 2? Yes, because we have two reasons, right? In one, this reason, I have y varying from 0 to 1. In this reason, I have y varying from 0 to 2. So first, I can do 0 to 1. So that would be 1 by 3. And second, I can do 1 by 3 dy from 0 to 2, which is 2 by 3. So how does my marginal density look like? This is 1 upon 3 and 2 upon 3. 1 upon 3 when x lies between 0 to 1, right? When x is between 0 to 1, I have 1 by 3. And when x lies between 1 to 2, I have 2 upon 3. So this is my marginal density.
So you're considering the entire area of 1 by 3, or you have to take for the first range from 0 to 1, you have to take only one as area and the other one as 2.
No. So what we are doing is, see, my first question first is key, what is the joint PDF, right? I should know what is the joint PDF. So for the shaded region, for this whole over D, I know that my joint PDF is 1 upon 3.
Yes.
Now I need to find the marginal. But I can see that even though this is uniform, I can see that my between 0 to 1, right? Between 0 to 1, my y is varying from 0 to 1. But between 1 to 2, for x, between 1 to 2, my y is varying from 0 to 2.
Correct.
Right? So let's say if I have to find, so that is why we have split in two cases. One case is for x between 0 to 1. So what happens when x is between 0 to 1? Then in that case, my fx of x is 1 by 3, which is fxy dy, and y is varying from, in this reason, my
0 to
y
1.
is varying from 0 to 1. And in the second reason, for x between 1 to 2, my y is varying from 1 to, sorry, 0 to 2.
Yeah. No, my question was that the area for the region 0 to 1 is 1 upon 1, right? And the other one is 1 upon 2. So do we not have to integrate 0 to 1 1 dy plus 0 to 2 1 by 2 dy?
0 to 1, 1 dy.
Yeah, because the area
No,
under the rectangle 0 to 1
no,
in
no. Because what my question says that xy is uniform in D. And
okay.
what is my D? D
Okay.
is this whole thing.
Okay.
Yeah. So even if you don't do the integration, maybe, so if I go to this 0 to 1 reason, if I fix my x, I can see that my y is varying from 0 to 1. So it is uniform. So I can just say that for x to be, for x lying between 0 to 1, it is just 1. This area is 1 divided by this total area, which is 3. And for this reason 1 to 2, I know for any x my y is varying from 0 to 2, and this area is 2, and my total area is 3, so 2 upon 3. Whatever you're more comfortable with. If you're more comfortable doing integration, do the integration. Otherwise you can just look
Ma'am,
at the
for
figure also.
solving second part in f x of x, why you take a 0 to 2 range?
Why I taken 0 to 2? Because see, now this is the second part. So this is for x lying between 0 to 1, and this is for x lying between 1 to 2. So for x lying between 1 to 2, you can see that your y is varying from 0 to 2, right? Your y is varying from 0 to 2, right? And we are integrating my fxy with respect to y. And how is y varying in this x, in this range of x? It is between 0 to 2. So I should integrate between 0 to 2.
Okay, ma'am.
Now what about fy? How will you find fy?
Ma'am, integration of
0.
1.
What is fy?
Ma'am, integration of 1 by 3 with the respect to x.
0 to 2.
0 to 2.
It's 2 by 3.
Okay, can someone tell me? I will just write it here maybe. So fy of y is what?
Ma'am,
Integral of
integration of 1 by 3
hmm,
dx
hmm,
range is 0 to
0
1.
to
Ma'am, it should be 0 to 1 and
0
then
to
1 to
2.
2.
0 to range. Tell me the range. What is the
1.
range?
0 to 1.
0 to 1.
Ma'am, can we not take directly 0 to 2?
Yeah, 0 to 2.
We'll take 0 to 2. This is for what? Y. Where is y? For which y you are telling me this? I mean, where does y belong? Y belong to where?
0 to 2.
0 to 2? Y belong to 0 to 2 or 0 to 1? Where does y belong?
Ma'am, 0 to 2.
0 to 1, right? Wait, maybe I'll draw separately. See, we have this x, we have this y. This is 0 to 1. This is 1 by 2. Okay. This whole thing is my reason D. Alright, this is my D. This is 0, this is 1, this is 2, this is 1, this is 2. Now I'm asking what is Fy of y? Okay. So you can see that I have y lying between 0 to 1 and y lying between 1 to 2. So if I have y lying between 0 to 1, then in that case it would be integral of fxy, which is 1 upon 3 dx for x. How is x varying when I'm taking y from 0 to 1? My x is varying from 0 to 2, which is 2 upon 3. Now what happens when my y lie between 1 to 2? My again fxy is 1 upon 3. I will integrate with respect to x, but now my x is lying from 1 to 2. So that would be 1 upon 3, right? So this is for when y lies between 0 to 1, and this is for when y lies between 1 to 2.
Ma'am, can you explain again, please?
We had to find fy of y, right? So fy of y is what? Fy of y is fxy dx, right? Now I should write the limit for x. What is the lower limit? What is the upper limit? So if I look at this figure, I can see that. So you have y lying between 1 to 2, sorry, 0 to 2, right? Now for y lying between 0 to 1, my x is lying from 0 to 2, right? If I consider y from 0 to 1, my x is between 0 to 2. But if I consider y between 1 to 2, if I consider y from 1 to 2, my x is between 1 to 2, right? You can say this. X is this is what? This is x is equal to 1. This is x is equal to 2, right? This is okay, right? So
Yes, ma'am.
if I take so fxy is what? This is 1 upon 3, integral of 1 upon 3 with respect to x, where x is varying from, so if I'm taking, if I'm looking at the case when y is between 0 to 1, I will have to take my limit of x from 0 to 2, which is 2 upon 3. But if I have to, if I am looking at 1 to 2 for y between 1 to 2, my fy of y would be 1 upon 3 dx, and x is varying from 1 to 2, which is 2 minus 1, which is 1, 1 upon 3, right? This is fine.
Yes, ma'am.
All right. So we have one a little tricky, I mean, little more difficult problem here. So this question is on independence. So the question says, suppose x follows exponential with lambda 1 and y follows exponential with lambda 2. Okay. Now it is also
Ma'am, for the above question, after we get this marginal, then do we have to compare against joint to see the independence, or do we stop there?
um, no, I was just telling you how to calculate the marginal.
Okay, ma'am. Thank you.
Okay. So, okay, the question was x is exponential lambda 1, y is exponential lambda 2. It is given to us that x and y are independent. Now you have to find the probability that x is greater than y. How will you proceed for this question? How will you proceed?
So we have to integrate uh, fxy where y goes from 0 to infinity. However, x limits are only from 0 y to infinity.
We have to integrate from,
Like x goes from y to infinity, but y goes from y takes all the values 0 to infinity.
okay, yeah, that's fine. So before that, I mean, if you have to find the probability, you need the joint PDF. You need the joint PDF to calculate the probability, right?
Yes, yes.
So how will you calculate the joint probability?
That will be just multiplication of the
Multiplication of these
marginals.
two.
Yes.
Yes, yeah. So my fxy would be fx of x times fy, right? Why is this? Because x and y are given to be independent. Now what is fx of x? X follows exponential with lambda 1. And what is the PDF of exponential? It is lambda e to the power minus lambda.
Then X.
What is the PDF of y? It is lambda 2 e to the power minus lambda 2 y. So this will become lambda 1 lambda 2 e to the power minus lambda 1x e to the power minus lambda 2y. So to find the probability now, so we have to find the probability that x is greater than y. So this is my line x is equal to y, right? So x is greater than y is this whole reason. It will I'll just keep on going, right? So this is my reason. And we have to find this probability. What is the probability that x is greater than y? Now, to find the probability that x is greater than y, this would be double integral fxy dx dy. Let's say I first, so what is my fx? Fx is this lambda 1, lambda 2, lambda 1, lambda 2, e to the power minus lambda 1 x, e to the power minus lambda 2 y, dx dy. So suppose we go and integrate first with respect to x. So if I want to integrate first with respect to x, what we will do? We will draw a horizontal strip parallel to x axis, right? So we'll draw a horizontal strip parallel to x axis, and from here I can see that my x is varying from this point, and this point is what? This point is x is equal to y, and it will go till infinity. So my x would vary from y to infinity. And how is y going to vary? So you know the limit of y is, so y is exponential. So y, like range support of y would be, sorry, range of y would be 0 to infinity, right? So y would be from 0 to infinity. So you just have to calculate this integral to get the answer.
But in this, we have to take care of one thing that
Hmm.
I came to know across while solving activity questions, that
Okay.
uh, first we have to do the x kind of it. I mean, integrate out the x, because it will give something in terms of y, and then y
Hmm.
integration
Yes,
will give some value. But if we
correct.
do ulta, like if we integrate y first,
Hmm.
then we will not get the answer. It
Uh,
remains.
no, no, you should get the answer.
Uh, I've tried for one of the activity questions. I think I couldn't get.
Okay,
If
maybe
you,
maybe we can do this for with respect to y. Okay. Um, okay. Let's do this with respect to y.
I mean, what I want to say is, first if we integrate out y, then we may not reach a figure. Okay, let's see.
Yeah, let's try this. So this is my reason, which is x is greater than y. So we want to first integrate with respect to y. So if we want to first integrate with respect to y, I'll make a vertical strip parallel to y axis. So now this is lambda 1, lambda 2.
Uh, okay, now I understood. But by doing
Hmm.
the second graph and changing the limits, we may get it. But I tried that doing on the same integral that we have on the first earlier
Okay.
page.
Yeah, you can't take the same integral because
Okay,
your limit will change.
correct, correct.
Yeah.
But if you just look at it from the integration point of view, the first page integral is also a valid integral, no?
No,
But
no,
if I
both
just
are
solve
valid integral.
correct, but in that first integral, double integral, if we solve for y first and then try to solve for x, we won't reach anywhere.
We solve for, yeah, because the limits are different, no? Here you're
Yes,
saying x from y to infinity. So if you want to first integrate with respect to y, then your limit should also be accordingly. You can't keep the same limit, but like integrate differently.
And ma'am, the way it's written, that's itself reads out that we are first integrating with respect to x, right? For the first, the above
Yeah,
one.
yeah, yes.
If we reverse, then we have to in fact reverse the limit as well.
Yes, limit also will get changed. So how is the limit changing here? Here now y is varying from 0 to x, whereas x limit is 0 to infinity. Okay. So you try this. I mean, it is already done in the lecture. If you find any difficulty while doing this, you can let me know later, maybe in the next session. But try this out. A little complicated integration, but it should be doable. So we just have our last topic left, which is conditional density. So suppose my xy has the joint density f of xy, okay? And fx and fy are the marginal densities of x and y. Then how do we write the conditional density? So the conditional density of y, let's say, suppose conditional density of y given x is equal to sum a. So this would be joint divided by marginal. So what is the joint? The joint is f of xy a comma y divided by marginal, which is f of fx of a, right? So this is how you will find the conditional densities. If let's say you had to find f of x given y is equal to b of some x, so this would be f of xy of x comma b divided by fy of b. So we are doing the same thing that we did in the discrete case. So conditional is joint divided by marginal. So here again we have to find the conditional density. So this is equal to the joint density divided by the marginal density. All right. So
Okay,
can
ma'am.
we so can we do for this question our non-uniform distribution case? So where the joint density was given as x plus y 0 for x y lies between 0 and 1, 0 otherwise. Can you find, so what was my fx? So I'll just write this was this for x lying between 0 to 1. Now can you find the probability, so the density, conditional density f of y given x is equal to sum a of y. What should this be? We have to find, we are given the joint. I have also given you the marginal of x. Now you have to find this conditional density y given x is equal to a.
Ma'am, x plus y upon
Hmm. X
Ma'am, we
plus
have to
y.
find in terms of A.
Yes, x is equal to a is given, right? I mean, around x is equal to a.
a plus y.
A plus y. So joint divided by
A plus 1 by 2 margin.
a plus 1 by 2. So this is going to be f of y given x is equal to a of y. So if you have to find the conditional, you just do joint divided by marginal.
Okay, ma'am.
Okay, so these were the topics that were covered in week 6.
Ma'am,
Uh,
could you
hmm.
please take one question from tutorial of week 5?
One question from
Tutorial of week 5. Tutorial 1, week 5.
okay, right. Mm. Yeah, so that was all from week 6. If you have anything, you can just let me know.
Ma'am, do we have TA sessions
Yes, we'll have the TA
tomorrow?
session. Yes, tomorrow. Yes, tomorrow is when we'll schedule. I think it is not scheduled it, but we'll schedule it for tomorrow.
Ma'am, at what time?
Evening only.
Ma'am, can you increase TA sessions?
Yeah, so we have already increased it. So I think it is not scheduled, but like we'll try to do more and more sessions.
Thank you, ma'am.
Okay, thank you.
How are the TA sessions notified?
It's there in the calendar. It gets updated in the calendar.
Okay. I have one request. Like in quiz one, no exponential distribution related problem was given,
Mm,
but in place of lambda, mean was given. Like mean is so and so.
mm,
So
mm.
that time for that syllabus, we did not know 1 by lambda is mean. So that means lambda is 1 by mean. So that
Why
alternate
is that
parameterization.
week four was week four we have discussed this, right? In week
Mm,
four
Yes,
is
ma'am.
continuous random variable.
mm, I don't. Maybe I have not attended these kind of sessions, but from lecture slides and all, we didn't know that. So that's how I got that question wrong. But if such alternate things could be mentioned somewhere, then it will be helpful for us.
What about the formula file? Because formulas were also given.
Formulas were given, but I
Mm.
don't think lambda means 1 by mean in case of exponentials. That information was not given, I think.
So yes, so
We knew the formulas. I mean,
you need the formula, right?
yeah. So lambda into exponential of minus lambda x. So some mean of some 10,000 miles for battery life was given.
Yeah. So if the mean
So
is,
yes,
but
so
we know this, no? We know that if x follows exponential lambda, then its mean is 1 upon lambda.
till week 4, I think it was not covered. It was after week 4.
Ma'am, it's there.
It should be
Like
in
week
week
5
4.
only deals with expected values of continuous random variables, if I'm not wrong. So
Ma'am, it's there in starts one also.
That's when it is there. That I know.
okay, I get it,
Mm.
ma'am. I may have
Yeah,
forgotten, but
yeah, yeah.
uh, so I kept searching for what is lambda in this case. So
Okay. Hmm.
yes, okay.
No, no,
And ma'am,
I
I
get it.
think
Yeah.
in week 0 also.
Because on Wikipedia it is mentioned lambda is
Like,
called a rate parameter and 1 by
yeah,
lambda is
different,
called mean. So
yeah, different places you get to see different things.
okay, okay.
Um,
So, ma'am, now how many TA sessions will be there in a week?
what?
Ma'am, so now onwards, how many TA sessions will be there in a week?
So TA sessions, we are just trying to change the days. This week you have week 6 deadline on Wednesday. So we'll schedule it for Monday. So we'll schedule the TA session for Monday. Then again you have a session on Tuesday, and this Thursday will continue. It will get updated in the calendar. Okay.
Okay.
Okay, ma'am. Ma'am, week 5, tutorial 1, last question.
Yeah. So the question was 5 tutorial 4, right? Tutorial 1. Okay. Question was, you have your random variable y, which is uniform in 0 to 20, right? I think. Yeah. 0 to 20. Y is max of. Okay. So x is uniform in 0 to 20, and y is defined as max of
4,
4 comma min of
8,
8 comma x. Okay. So now what we have to do is we have to find the CDF of CDF of y. Okay. So to find the CDF, what do? We need to find Fi of y. And what is this? This is the probability. Can you just give me a minute? Okay, fine. So we have to find the CDF of y. So what is this? This is the probability that y is less than equal to y. Right? So let's say this is my 0 to 20. This is 1 upon 20 fx of x. And this is my x. Now you will have to look at different cases for this y. So The y is, so first we should look at min of 8 comma x. Min of 8 comma x. So what happens if x is somewhere between 0 to 8? If x is between 0 to 8, then what is the minimum going to be? X.
Yes, ma'am.
Now what happens if min of if x, sorry, what happens if x lies between somewhere between 8 to 20? Then in that case min of 8 comma x would be 8,
Yes, ma'am.
right? So what would my y would be? Y would be max
4,
of 4 comma x, and it would be max of 4 comma 8.
4.
This is for the first case and this is for the second case, right?
Yes, ma'am.
Now this is my y. Now again, let's split this again. So now I'm talking about max of 4 comma x and max of 4 comma 8. So max of, and how is my x varying? X is varying from 0 to 20. So y would be, so if I take my x between 0 to 4, so this is my 4. So any x between 0 to 4, now if I have to take max of 4 comma x, it will be 4.
Yes, ma'am.
Now if I take any, and now next is 4 comma 8. So if I take any x between 4 to 8, right, the max would be
8.
max would be 8, right?
Yes, ma'am.
So this is 4, this is 8. I'm taking some x over here. So max of 4 comma 8. So first we had 0 to 20. Then we did 8 and we got this, okay? Then I have this, okay? Now we have 4. So if I take any x over here, I will have max to be 4. Any x. No. So if I take any x over here, right? Let's say I take this x. So max of this, like max of 4 comma x would be x, right? Max of 4 comma x.
Yes,
So if I take any value between here, whatever value I take, that would be my maximum. So that would be x. Now if I take any value between 8 to 20, 8 to 20, then what we have to do?
Ma'am,
Then max
x
of
is
4
great,
comma,
x
sorry,
is greater than 8 or is equal to 8, then it's 8 now.
can you repeat?
Ma'am, if x is greater than or is equal to 8, then the value is 8 now.
So I'm not able to hear you. Then what? If x is greater than equal to 8, then
Ma'am, then the value is 8.
this might take some time. We have to, I'm just running late, so we'll have to close the session. Disha, can we do this question tomorrow?
Okay, ma'am.
Because it will take some time and I'm running late for something. Okay, we'll
Okay,
do
Ma'am,
it
ma'am.
tomorrow. Okay.
excuse me, ma'am.
Yes.
Ma'am, I also have one doubt from activity 5, week 5. Will you take it tomorrow, please?
Can you mention the activity?
Ma'am, activity 5.1, last question. Actually, I have
Activity
to.
5.1, last question. Okay.
Yes, ma'am.
We'll do it tomorrow.
Okay, ma'am. Thank you, ma'am.
All right. Thank you.